All right, so see if you guys can give me the actual chemical names of the following compounds. Okay, so write those ones down, okay? Give them a try. Give you a couple minutes here while I do the attendance, and then we'll go through them together. All right, let's have a look at these ones here. So our first one, we've got magnesium and we've got chlorine. Is that ionic or molecular? It's ionic. Magnesium is a metal. All right, so we follow our ionic naming rules, okay? We'll write the name of the metal, magnesium, and the name of the nonmetal, ending in I. Or I. Okay, do I need any Roman numerals? Okay, so that one's done. That's all we have to do for that one. All right, the second one here. Okay, we got sulfur, we got phosphorus, ionic or molecular? That's molecular, they're both nonmetals. So, what prefix do I need to put in front of sulfur?
Right.
Okay, and I write sulfur in its full unaltered name. Okay, and then what needs to go in front of phosphorus? Hexa, right. And I need to change that to phos. Good. All right. The next one there, I've got sodium, and then I've got a polyatomic ion. So is this ionic or molecular? Ionic. You got an ion and a metal. Okay, so I'll write same naming rules. I write the name of the metal, sodium, and then I write the name of the nonmetal. In this case, it's a polyatomic ion, so I just write carbonate. Okay, do I need any Roman numerals for that one? No, sodium only has one possible charge. Okay, now I have iron and sulfur. Ionic or molecular? Yeah, it doesn't get more metallic than iron, right? Like iron is kind of our typical metal. All right, so iron and then sulfide. What do I need? This one needs Roman numerals. Okay, we always have to check that at the end. So what we do, okay, as a reminder, we go to our non-metal. Sulfur's in group 16, where everything has a -2 charge. Okay, there are 3 sulfurs for a total of 6 negative charges. So I've got to get 6 positive charges from 2 irons. 6 divided by 2. This iron has a +3 charge, so Roman numeral 3, subscript in brackets. Okay, in between. Questions on that one? Okay. I would say this is probably about as tricky as they get. Okay, what kind of compound is it? Ionic. And it has Roman numerals and a polyatomic ion. It's got both. Okay, it's got it all in every way that's, you know, good or bad, however you want to look at it. Okay, so I'm going to write the name of the metal. Right? I'm going to write the name of the nonmetal. What's PO for? Phosphate. Okay, now I need my Roman numeral. So if I go to my polyatomic ion chart there, it says that this has a -3 charge, and there are 2 of them, for a total of 6 negative charges. Okay, that means I need to get 6 positive charges out of 3 leads. That means each lead must have a charge of +2. So lead, Roman numeral 2, phosphate. Okay, that gives you a pretty good idea of the mixture of types of questions you're going to see tomorrow on your quiz. Okay, I'd say there'll be, you know, a small number of easy ones, like the first 2. Okay, probably a larger number of kind of moderate difficulty ones, like, you know, the second 2, and then there'll be a small number of hard ones, like the last one. Okay, I'm pretty sure I have 5 questions like this where we go from formula to name, and 5 where we go from name to formula, which is what we're going to work on right now. Okay. Now, we talked about that a little bit at the end of class yesterday. How do we write the formulas when we're given the name? So, For ionic compounds, okay, we still, I mean, the first step is still, is it ionic or molecular? If we decide it's ionic, our first step is to write the formula for the metal and its charge. And then write the formula for the nonmetal and its charge. And then drop and swap. And then you're pretty much done, except for one little thing that can come up occasionally. Okay, so let's just try this first off. Let's try with okay, so let's say I give you that calcium fluoride. If I follow these steps, the first thing to do is to write the formula or symbol for calcium, Ca. Calcium's charge, 2 plus. Right? Then I write the nonmetal, fluorine, symbol is F. It's in group 17, so its charge is -1. Now what do I do? Drop and swap. Okay, simple as that. So the 1 goes here, but we don't write 1s, so that's gone. Okay, and we bring the 2 down here. CaF2. All right, everybody good with that? Okay, so here's another thing that could come up. Let's try this one. Nope. Okay, 6. Let's not do that. I picked a bad one. Manganese instead. Manganese 4 sulfide. Okay, so if I follow the steps, I write the formula for manganese. Mn. What does the Roman numeral tell me?
The charge is 4.
Right. This one, the charge is 4. It says use the 4 charge because you got 2 to choose from. This is the one to use. So whenever you see a Roman numeral, it's actually saved you time. You don't need to look it up on the periodic table. And then it's with sulfur, okay, which is a -2. Now, if I drop and swap this, I'm going to be left with 2 and 4. Is that right or wrong? It's got to be reduced down to 1 and 2. So this would actually be wrong. And I would absolutely, on a unit exam, make a multiple choice question with one like this in it, and I would have Mn2, okay, S4 as one of the options. Okay, testing exactly this idea. Ionic compounds must be reduced if possible. All right, so our correct answer here is actually 1 and 2. You only do that with ionic compounds. Okay, molecular compounds, the prefix numbers are gospel. They tell you that it's 4 and 2, it's 4 and 2. Okay, you don't reduce molecular ones. Always reduce ionic. Okay, what if I had this stuff? Let's try. Did I still write an ionic compound up there? Right. Ammonium is an ionic ammonium carbonate, sorry, is an ionic compound. Ammonium is a polyatomic ion. It's the only one, remember, that acts like a metal, because it's the only one on there with the positive charge. Okay, so I still follow the same rules. Here's my metal, NH4 plus 1. Carbonate, CO3 minus 2. Okay. Can I still drop and swap? Yeah, absolutely. Okay, nothing's stopping me here. Okay, so I'm going to drop the 1 down here, so that's taken care of. And then the 2 needs to go here. But I can't leave it like that. What do I need?
Brackets.
Brackets, yeah. Does the 2 go inside or outside of the brackets?
Outside.
Outside, right. Just like in math, it means to multiply everything inside the brackets, okay, by 2. That's about as tricky as they get. And the only way I can make that trickier would be to give you a multivalent metal and a polyatomic ion. Okay, something like that. Everybody okay with that one? So that should seem mostly familiar, right? I mean, the only thing new here is that and what to do with the polyatomics. The drop and swap is fundamental. If you can do that, you can apply it to any ionic compound. All right, molecular. Molecular are super easy because they tell us what numbers to write with the prefixes. Yeah, and you just go by that number. All right, whatever it tells you, you write those in and then use the prefixes to get the number. Simple, right? So let's say I gave you this one. Okay, definitely molecular, it's full of prefixes. Okay, so I would write the symbol for phosphorus. How many phosphorus do I have?
2.
Okay, and how many oxygen do I have?
4.
Okay, do I reduce that?
No.
No. Okay, I do not reduce molecular compounds. Right? They're not sharing electrons. There's no ratio for them. Okay, they just go together whatever way makes them happy and allows them to share their electrons. Right? Making sense? There is absolutely nothing new for molecular from what you learned last year. It is exactly the same. Okay. Then, here is what I'm going to do. I want you guys to quickly write down, oh sorry, that was chemical names. We did that one already. I meant to have you guys write down the other steps there. There we go. Okay, can I get you guys to write those steps down? Okay, I'm just going to scroll it up. The top says writing formulas. I'm just going to scroll it up to there so that you can see all of the words. Okay, give you a couple minutes to get those written down. I just have to grab something from the photocopier and then we'll get going. Okay, you have access to the keys for all of the worksheets that we're going to do in this course, quite frankly. Okay, so if you go into Google Classroom when you're at home, if you're practicing and you want to see this stuff, go into the classwork tab and you'll see that I posted down here in course materials, chemistry worksheet keys. Okay, in there are the keys for all of the worksheets that we will do. This is the one we're working on right now, is the naming ones. So if you're wanting to practice at home, you can refer back and see if you did them right. One caution on that. Only do about 4 before you check your answers, right? Because I've had people who do like 50, and then they go back and they're like, oh no, I've been making the same mistake every single time. And now I have practiced that mistake 50 times, and it is cemented in my brain as the way to do this. Okay? So before, make sure you're doing them right. If you're not, then figure out what's going wrong and come see me. Okay? Just don't want you to practice doing something incorrectly. Okay. All right, so let's get going on those. I'll give you a few minutes. We'll do the first 4. Okay? Give you another few minutes. You guys go as far as you can. Get as far ahead of me as you can on only the circled ones for now. Okay? Only the circled ones. All right, so number 1, I got calcium phosphide, ionic or molecular? Ionic. Okay, so I'm going to write then, according to the rules, the symbol for the metal and its charge, so Ca, 2+, and then symbol for the non-metal, P, and its charge, -3, and then I'm going to drop and swap. Okay, so 3 is going to come here, 2 is going to go there. Can I reduce that? Nope. All right, so we leave it that way. Questions on that one? Okay. For number 3, I got manganese, Roman numeral 4 oxide. As soon as I see a Roman numeral, I know it's ionic. Okay, so I'm going to write manganese, Mn, and the Roman numeral tells me to use the 4 plus charge, and it's with oxygen, which is a -2. All right, now I drop and swap. 2 goes here, 4 goes there. I can erase those. Am I done?
No.
No. All right, those can both be divided by 2, so I have MnO2. Okay, and then number 4, again, I have Roman numerals, so I know it's ionic. Write the symbol for the metal, Fe, it's a 2 plus. Okay, sulfur, it's a 2 minus. Do +2 and -2 add up to 0? Okay, so I could swap and drop these and then reduce the 2's to 1's, or I could just recognize right away that, good. All right, we're already there. Okay. All right, and then number 8 is the 4th one here. So ammonium sulfide. We did an example with ammonium. I find that's one that often tricks people because it just looks weird and they're trying to find ammonium as an element and it's not. Okay, so just keep in mind that this is an ionic compound because ammonium is a polyatomic ion with a charge of +1. It is with sulfur, which has a charge of -2, and we just do the same thing we always do. The 1 goes there, the 2 comes here, and I'm going to make sure we know that we have to have brackets around that. Okay, I'll give you a little bit more time before I go through the next 4 there. So number 9 is our next one. We got nickel 2 bromide. We see a Roman numeral. Okay, we know this one is ionic. Symbol for nickel is Ni. The Roman numeral is telling me use the 2 plus variety, and it is with bromine. All right, so bromine is in group 17, so it's a -1, and we drop and swap. Okay, should be left with that. I would say that's one that I would consider to be fairly easy. All right, mercury 1 sulfate, ionic or molecular? Ionic. Mercury is a metal, right? And we got a Roman numeral. So, symbol for mercury is Hg. Okay, the charge according to the Roman numeral is +1, and it is with sulfate, which is a -2 according to your table. Now we drop and swap. Okay, the 1 goes there, 2 goes here. Okay, and you're done. You could, if you wanted to, enclose that in brackets. It's not wrong. It's also not necessary, but okay, it wouldn't be wrong if you did. Questions on 11? For number 15 here, diphosphorus pentaoxide. Ionic or molecular?
Molecular.
Molecular, right. Okay, how many phosphorus do I have?
2.
Okay, and how many oxygens?
5.
5. P2O5. Right, and was that the 4th? No, we have one more. Okay, up to 18 here. So nitrogen dioxide, ionic or molecular?
Molecular.
Molecular, yeah. Nitrogen and oxygen are both nonmetals. How many nitrogens are there? Just 1, yeah, because they didn't put a prefix in front of it. Okay, how many oxygens?
2.
2. Okay, now just so you know, guys, every time we do one of these, I talk through every one of the steps, which probably, gets annoying. Know that I'm doing that because I want to reinforce those steps. Each and every time, I'm going to talk through those, even if it annoys you. Okay? I just want to always talk through those steps so you're constantly hearing them and getting them set in your mind. All right, keep going there, guys. All right, so we're looking at number 19 here now. Phosphorus trichloride, ionic or molecular? Molecular. Those are both nonmetals. How many phosphorus do I have in that compound?
1.
Just 1. Okay, how many chlorines?
3.
3. Okay, PCl3 for that one. For number 21, we have potassium carbonate, ionic or molecular? Ionic. Potassium is a metal and carbonate is a polyatomic ion. So potassium would be a +1. Carbonate, which is CO3, okay, is going to be a -2. So when I drop and swap this, the 2 is going to go here. The 1 would go there, but we don't write them. And I'd be left with either K2CO3, or I could bracket the CO3 if I wanted. All right, number 24. Okay, ammonium hydroxide, ionic or molecular? Ionic, but they're both polyatomic ions. Okay, it does not in any way change what we do. I still write my metal, that would be ammonium with a +1 charge, and my nonmetal, that would be hydroxide with a -1 charge. Okay, when I drop and swap, are we good? Okay, I got a +1, I got a -1. I can write it like that, or this will look a little weird though. I could do that, okay? They just both have to be in their own brackets. You can't do like just one set of brackets that encloses the whole thing. That looks weird, okay? All right, one more, right? Okay, number 27, dinitrogen pentaoxide. Ionic or molecular? Molecular, both nonmetals. N2O5. Okay, keep going there, guys. Almost done that page. And what do we got? 3 left. I'll give you a couple minutes and we'll do those. All right, let's look at the last 3 on here. For 29, I've got aluminum nitride, ionic or molecular? Ionic. Aluminum is a metal. Okay, so Al, charge is 3+, nitride, charge is 3-. All right, +3 and -3 add up to 0. Okay, then we're good with ALN. That would be it. Do I need any Roman numerals? No, I definitely don't, because I wrote a formula. But you'd be surprised how often I see Roman numerals creep into formulas. Should a Roman numeral ever appear in something like this? Only ever in the name. Okay? All right. Number 31, ammonium carbonate. Ionic or molecular? Ionic. That's another one of those ones. This has got 2, okay, polyatomic ions. NH4 with a charge of +1, and carbonate, CO3 with a charge of -2. Okay, the 1 would go there, the 2 goes here, and I enclose that in brackets. And the last one, calcium phosphate, ionic or molecular? Ionic, calcium's a metal. All right, so Ca, 2+, phosphate, PO4, that's a -3. Okay, drop and swap. Is that making sense? Is there really anything new from last year? Other than, I gotta use brackets sometimes, okay? Otherwise, fundamentally, you're doing exactly the same thing you did last year. All right, well, let's have a look at the other way. Okay, so on the worksheet entitled Naming Compounds, looks like this. I would like you guys to do 4, 5. Okay, so 4, 5, 9, 11, 12, and 13. 18 and 19. 27 and 28. And 30, 33, 36, 37, 39, and 40. All right, I'll give you a few minutes. We'll do 4. Give you another few minutes. We'll do 4, just like the last time. All right, let's look at the first 4 here. Okay, so number 4, I've got CaSO4, ionic or molecular? Ionic, yeah, okay, because calcium is a metal, so I write the name of the metal, calcium. I write the name of the non-metal. Because it's a polyatomic ion, I don't change the name. Do I need any Roman numerals? Calcium is always a 2+, okay, so we're done. Calcium sulfate. Number 5, ionic or molecular? Ionic. Aluminum is a metal. All right, so I write aluminum, and then I write bromide. Do I need any Roman numerals? No. No. Okay, that one's about as easy as they get. Number 9. This one can sometimes be tricky. Ionic or molecular? Ionic. How do we know hydrogen's acting as a metal? It's first, right? Anytime it's first, it's behaving as a metal. Plus, it's in with a polyatomic ion. All right, so write the name of the metal, hydrogen. Write the name of the non-metal, nitrate. Okay, do I need any Roman numerals? No. All right, number 11, NH4Cl, ionic or molecular? Ionic. NH4 is ammonium. Okay, that's another one that can trick people when they see it in formula form because it starts with nitrogen. Okay, so ammonium chloride. Right? Don't need any Roman numerals on that one. All right, I'll give you a few more minutes here to get ahead of me again. I think most of you already are, but I'll just give you a few more minutes. All right, so number 12, I have SO4, ionic or molecular? It's molecular, but it's tricky, right? Because is there a polyatomic ion with exactly the same formula? There is. How do I know that this is a molecular compound and not a polyatomic ion?
It's not within the
Right, it's not in a compound with something else, particularly a metal. Okay, that does happen that you can have molecular compounds that have the same formula as a charged particle. Okay, so this stuff will be sulfur. I don't need a prefix in front of that because there's only one, but what prefix needs to go in front of oxygen? Tetra. So this will be sulfur tetraoxide. Okay, 13. Ionic or molecular?
Ionic.
That's ionic, yeah, okay, because it's ammonium again to start, and it's with nitrate. Okay, so this is ammonium nitrate. Now, interesting thing about this particular compound, it is actually going to be one of the unknown compounds in our lab next week, okay? So I will tell you this about it. If you have ever used one of those cold packs where you pop the little water bladder and you shake it and the crystals dissolve when it gets cold, those are the crystals. Okay? Ammonium nitrate has an endothermic reaction when it dissolves in water and it gets really, really cold. Okay? So maybe when we're trying to find things out next week, you have one that gets really, really cold when you put it in water. Might be that one. Definitely that one. Okay, that's 2, 18 and 19. Okay, got carbon and oxygen. Carbon monoxide, that's a molecular compound. Okay, dangerous stuff. You probably have detectors in your house to alert you to the presence of that gas. Okay, it is highly toxic. Actually, what it does is when you breathe it in, it bonds to hemoglobin. That's the stuff on your red blood cells that normally carries oxygen. But if this bonds to it, it doesn't come off. Okay? It bonds to hemoglobin more tightly than oxygen does. It occupies all the spaces, and your blood can't carry oxygen. And you get sleepy, you die. Because you basically just, you don't suffocate. You can still breathe, but the oxygen doesn't go to your cells. All right, number 19. Okay, we've got nitrogen and oxygen, ionic or molecular? Molecular, okay, so this, do I need a prefix on nitrogen?
No.
Okay, what prefix goes on the oxygen? Okay, nitrogen dioxide. All right, I'll give you a few more minutes on those four. For number 27, we have Al2O3, ionic or molecular? Ionic, aluminum's a metal. Okay, so we write the name of the metal, aluminum, okay, write the name of the non-metal, ending in I. Do I need any Roman numerals? Aluminum is always a +3, it has no other charge, so aluminum oxide is good. All right, number 28, PBS. Okay, ionic or molecular? Ionic, lead's a metal. Okay, so lead, sulfide. Do I need Roman numerals?
Yes.
Yes, lead can be a 2 or a 4, so I've got to figure out which one it is. Sulfur is always -2. There's one sulfur, there's one lead. Do they have the same charge? Okay, so the charge on lead is +2. So we put the little Roman numeral in there, lead 2 sulfide. Or number 30, Fe2O3. Ionic, yep. Okay, so we write the name of the metal, iron, write the name of the non-metal, oxide, Roman numerals?
Yes.
Yes. Okay, oxygen's always a -2. There are 3 oxygens, that's 6 negatives. So I gotta get 6 positives from 2 of these. 6 divided by 2, this is iron 3 oxide. All right, and then number 33, SnF4, ionic or molecular? Ionic. Tin is a metal. All right, so tin fluoride. Roman numeral? Yeah. Okay, tin can be a 2 or a 4, I think. Okay, so fluorine's always a -1. There are 4 of them, so that's 4 negatives. There's only one tin, so it has to have a charge of +4. So tin, IV, and fluoride. All right. How many people are done all the way to 40? Yeah, okay, let's just look at it then. 36, NiI3, ionic or molecular? Ionic, nickel's a metal. Okay, write the name of the metal, nickel, write the name of the non-metal, iodide, Roman numeral?
Yep.
Yep, nickel can be a 2 or a 3. Okay, in this case it would appear that it is a 3 because iodine has a charge of -1 and there are 3 of them. So, okay, 1, 2, 3. All right, number 37, CS2, ionic or molecular? That's molecular. Carbon and sulfur are both non-metals. Okay, do I need a prefix in front of carbon?
No.
All right, so carbon and what goes in front of sulfur?
Di.
Di. All right, and then for 39, P4O8. Ionic or molecular? Molecular. Okay, is there a mistake? Should that be reduced? No, because it's molecular, right. Okay, so what prefix goes in front of phosphorus? Tetra. Okay, and then it would be, what would go in front of oxide? Octane. Okay, now so you know, this is exactly the kind of thing I would put on a quiz, except I'd go the other way. Right? I would give you this name, tetraphosphorus octaoxide, and tell you to give me the formula. And I would catch some people reducing that. Okay? That's exactly the kind of question I would put on there to test whether you know that rule or not. Okay. All right, and then on number 40, Al4C3, ionic or molecular? Ionic. All right, now write the name of the metal, aluminum. Write the name of the non-metal, ending in ide. Carbide. Any Roman numerals? Okay. How are we feeling about that? Okay. Before we move on to any other ones, I want to talk quickly about your quiz tomorrow. Okay. So obviously you have your first quiz in this class tomorrow. Okay. It'll just be written in here. If you have accommodations through learning supports, okay, and you don't want them, let me know because otherwise I'm taking all the accommodation tests to learning support for tomorrow. Okay, so if you don't want that, let me know. That test normally should take about 25 to 30 minutes, but I give the entire class. Okay, that way if you need a little extra time, whatever, okay, there's time. Okay, so know you have the entire class tomorrow to write that quiz. That's 50 minutes. Okay. You can have your periodic table for that, okay? Provided you haven't, written all kinds of cheat notes all over it. Make sure you have something to write with, obviously, for that. And I will, have those entered in, marked and entered in fairly quickly. You should know what you've got before the weekend. On that, you will know what you had before the weekend. You probably want to do fairly well, or it may affect your weekend plans because your parents will be able to see it in Power School. And it will be the only mark you have in Power School for a minimum of 7 days, because I'm not taking anything else in until next week's quiz. Like, we are doing a lab next week, but it's not due next week. Okay, so this will be your mark for 1 full week. Okay, so you might have some explaining to do, okay, if things go poorly. Now, do you have tons of ability to prepare for that quiz? Okay, here's what you need to do tonight. If you haven't done the quizzes, do them. Read through your notes for lesson 1. I'm going to ask you things like the points of the atomic theory, a few of the important people. Okay, there's 8 questions on lesson 1. Okay, that's history and structure of the atom. And there are 8 questions on naming and formulas. 4 like this, where I give you the formula, you write the name. 4 where you go the other way. I give you the name, you write the formula. Right? That's what you can expect for tomorrow. And the formula ones, there'll be an easy one, a couple moderate, one hard. So that's what you can expect for tomorrow. Okay, let's do on the next one here. So it's the final formula review is the name of the worksheets. Okay, it looks like this. These are not the ones we're doing. Okay, I will circle the ones we're doing. So on the top set, I want you to do 3, 4, 6, 7, 8, 9, 11, 12, and 16, and 19. Okay, and then on the bottom set, okay, I want you to do 4, 5, 9, 10, 11, and 13. Okay, give you a little bit of time to get ahead of me there, and we'll go through those. Hey, carbon monoxide, ionic or molecular? Molecular, both are non-metals. Okay, how many carbons are there? Just 1. How many oxygens are there?
1.
Just 1. Okay, we had that, but we had it as 1 going the other way. Okay, number 4, chromium 3 fluoride, ionic or molecular? Ionic. Okay, so we write the formula for chromium. Okay, and we write its charge. I know its charge is +3 from the Roman numeral. And it's with fluorine. Okay, fluorine is in group 17 where everything has a -1 charge. And I drop and swap. So the 1 goes there, we don't write those. The 3 goes here. And we're good. Okay. Number 6, dinitrogen trisulfide, ionic or molecular? Molecular. All right, how many nitrogens?
2.
Okay, how many sulfur?
3.
Okay, done. And 7, sometimes hard to find arsenic. It's not one we use very often. Also, a popular medieval poison. Okay, arsenic is right here. Okay, it is AS. Okay, so how many arsenic are there? 2. Okay, and how many bromine?
4.
Okay, should I reduce that?
No.
No, I should not, because it's molecular, right? Just gotta really watch for that one, right? These are the questions you need. I speak them out, but these are the questions you need to ask yourself in your head every time you do one of these. All right, I'll give you guys a few more minutes to get ahead of me again. You probably already are, but. Number 16, disilicon octachloride, ionic or molecular?
Molecular.
Molecular. Okay, how many silicone?
2.
2. Okay, how many chlorine? 8. Reduce? No. All right, number 19, palladium 2 phosphide. Ionic, yeah. Okay, so palladium, I believe, is PD.
Yeah.
I think so. I don't use that one very often. And it's a +2. Thank goodness that's a Roman numeral because I have no idea what the charges are. Okay, and it's with phosphorus. All right, and that has a -3 charge. So drop and swap. 3, 2. Okay, can't reduce that, so we'll leave it the way it is. All right, from the lower section, number 4, copper 1 carbonate. Okay, ionic or molecular? Ionic. Okay, so Cu plus 1, carbonate is polyatomic, CO3. That's a -2, drop and swap. Cu2CO3. All right, and then number 5, nickel 2 nitrite. Okay, oftentimes people get nitrite and nitrate mixed up. They just don't kind of look carefully enough. Right, so ionic or molecular?
Ionic.
Ionic, okay, so nickel, and this is the 2+ nickel because the Roman numeral tells us that, and it is with nitrite, which is NO2, which has a -1 charge. All right, so we drop and swap, the 1 goes there, okay, the 2 is going to go here, and what else do I need to do? Brackets. Okay. All right, give you a couple minutes on the last 4 there, and we'll talk about it. All right, so our last 4 here, number 9, we've got potassium permanganate, ionic or molecular? Ionic, yeah, potassium is a metal. All right, so potassium is K, it's a +1, permanganate, MnO4, it's a -1. Okay, +1, -1, seems like it adds up to 0 to me. Do I need to do anything else? No, just erase the charges. Okay, remember, those are the purple crystals that can stain your skin if you play with them. Don't play with them. Okay. All right, number 10, iron 2 hydrogen carbonate, ionic or molecular?
Ionic.
Ionic, yeah. Okay, so this is iron with the 2+ charge, and it is with hydrogen carbonate, HCO3, which has a -2 charge, I believe. Okay, is that already good the way it is? Right, or am I wrong on hydrogen carbonate? Oh, it's only a -1. Sorry, it's a -1. Okay, now I'm not done. Now I have work to do. Okay, so I've got to drop and swap. The 1 will go there. That's taken care of. 2 goes there. Now that's better. Okay, should look like that. All right, number 11, nickel 3 phosphate. All right, ionic or molecular? Ionic. Okay, so nickel with the 3+ charge this time, and it is with phosphate, PO4, which is a -3. That one good? Yes. Yep. NiPO4 for that one. All right, and last one here, lead 4 chlorate, ionic or molecular? Ionic. Okay, so Pb with the 4+ charge and chlorate ClO3. Yep. Yeah. And it's a -1. Okay, drop and swap. So the 1 goes on the lead, and the 4 needs to go right there. Okay, you have a pretty good idea, excuse me, of what you need to go over tonight in preparation for your quiz. Guys, you don't need to study like hours for your quiz tonight. Okay, if you've been doing the quizzes throughout the week, okay, you're getting this stuff, all right, then don't spend a huge amount of time. I do want you to do some prep, okay? I left you an entire worksheet, completely unfettered, okay? So you can have a look and maybe pick a few off of there and try them tonight for practice. You have a key you can check on Google Classroom, okay? If you haven't done the practice quizzes, I would certainly look at those. Okay, whoops, don't pack up, still time. Okay. Coming up here next week, okay, I've kind of brought you in slowly, right? Like you've only had one thing you've had to do for me. There's been no assigned homework yet, Okay, know that assigned homework is gonna start next week with your first lab report. Okay, now, we have time to work on our lab reports a little bit in class, but probably not enough for you to do a good job and have it completely done. It is gonna require you to do some work on your own in addition to prepping for that week's quiz. Okay, so as we progress here, okay, next week, we probably won't spend much time on naming. We're gonna go straight into properties of compounds, okay, getting ready for the lab, all of that kind of stuff. Then we'll talk about water, properties of water, solubility, and then next week's quiz will have naming, solubility, properties of compounds on it, because that's what we'll talk about next week. Okay? Then the week after that, probably be more about reactions, because we'll be getting into that. Okay? Before you know it, it'll be Thanksgiving and you'll have a unit exam. Okay? It's really gonna start to fly. So my message here is don't panic. And don't panic because you're gonna stay on top of things. Start planning. You're always gonna get plenty of notice from me of what's coming up so that you can pick away at it in small chunks rather than, oh crap, there's a giant boulder coming down the hill at me. Okay? Little rocks are easy to get out of the way of. A big boulder, okay, kind of a big deal. So don't let it get to that point. Okay? Do a little bit every day. You're gonna find it's not nearly as stressful. Okay? All right. We're good there for today.